Hello everyone, I would like to continue chapter 7, section 7.4. We talk about estimating the population proportion with confidence interval. This time 7.3 is kind of introduce you how to find the central limit theorem a requirement before you find SE, and then you can figure it out some probability and figure it out something related to 95% confident or 95% relate to empirical rules, right? 7.4 is more focusing on finding the interval that contain the contain the data that contain the data. We call that data is the true populations. So the confidence interval telling us like the value from here to there will be the true value population based on the data given, and you can compute and figure it out that. And the example, so right here we're talking about birth control, and they do survey 1,504 American adults, and they ask them if they supported or oppose the requirement that private health insurance plans cover the full cost of birth control. The poll found that 61% of the respondents supported this equipment. So this 61% you all can consider as P, or maybe P hat. In the survey they given us, the sample size is 1,504 people. So they were asking us what percentage of our American adults support this equipment. So to find the order percentage, so first we follow the order. So we do have the our estimated P hat is unbiased all the time, right? That's true all the time. The population perimeter is very close to 61%. And like I said, in 7.3, between P and P hat is very similar. They're just estimating of each other. They kind of similar. So you can write P or P hat. To me, it doesn't matter since it's kind of estimate to one another. Follow the step with the central limit theorem. You're checking for all this random sample is satisfied with all three conditions. And then you can jump to a step that finding the standard error by using the formula right here. We are having the formula, we're having standard error is 0.0126. So this can be considered as the standard deviations. And right here, they give us more like a large, it's like not really in order. So, but I recommend you to write in order first, and then you write a step 2. But it's supposed to be step 3 and follow. Look like number 3 right here combine step 2 and 3 in the central limit theorem of the sample distributions. So after you find the standard error by using this formula, you keep this in mind. So later I will spend time to run StatQuant for you to find all the probability. We're using StatQuant to find probability and confidence interval. Of course, you can compute by hands. But if you compute by hands, then you having the any calculator is fine. So right here again, for every problem related to sample distribution, all the time we they kind of mention with we call 95%, or we call empirical rules. All the time, which they mostly focusing on 95%. And if they asking the question relate to this, what you need to do is you just like take the P hat or P minus or plus the standard error, right? And you have the value. So right here, 2 times the standard error, because we're talking about 95%. So 2 times the standard error, which is we found the standard error is 0.0126. previously, you time that by 2 because you're talking about 95% chance. And you got a value right here. You take the p hat or p plus and minus that to get the interval. We call this is confidence interval. Like I talked to you a bit in section 7.3 about 95% empirical rules, and that is the way they find the confidence interval. So this is just the same thing. Okay. So it's look like right here we found a confidence interval like this, and confidence interval telling you is two things. This is the range of plausible value, is a good values for population perimeter, which is a good estimate that the data between this 95% will contain the true value of the populations. That's what it means. The second meaning is the confidence level, which expresses our level of confidence that the interval can, you know, the interval, right? The interval is like the value from here. For example, I say like from negative infinitive to 10, for example. So all the value from negative value to number 10. That is what it means, the interval. So confidence interval is similar. It's just an interval that contains the population perimeter. Okay. Confidence level tells us how often the estimation is successful, or the measure of the success rate of the method, not of any one particular interval. Margin of error is another name. So margin of error is we now talking some problem relate to the number of the standard deviations. Okay, so and we have learned. So later I will give you the value z. So in this case, when they're talking about margin of error, is it's kind of look like margin of error apply when we find the confidence interval. So let me go back to previous slide. This slide. The margin of error for this case, the margin of error in this case will be this. Okay, or this margin of error is 2 times SE. If they're talking about 95% confidence interval, then that will be the case. Sometimes this number changing. Okay, so these two combined, depend on the question, they make this become Z star. Or maybe right here, I'm sorry, Z star will be the number 2 right there changing. The number 2 changing, we call Z star. SE you compute the same, but these two combined, 2 times SE for this case 95% we call margin of error. Okay, they got different now they give us names for it. Go back to margin of error. Remember, margin of error is a new name for Z star times SE. Z star is changing depend on how many percent confidence interval that they request us to find. Usually they request us to find 95% confidence interval. They roughly estimating 2 will be Z star for 95%, but actually will be 1.96 for 95%. For later you will see the table. And sometimes they're asking for like, I would like to find 99.7% confidence interval, or sometimes they asking for, I would like to know is 90% confidence interval. So those kind of value, Z star will be changing depend on the number that they change. SE will be the compute by hands like we do before in 7.2 or in 7.3 and beginning 7.4. So you will start practicing finding SE from 7.3, okay? 7.4, you find SE before you find margin of error. like I showed you earlier, margin of error will be Z star times SE. For the case 95% will be 2 times SE. Okay, so here is a table. We got Z star will be 80%. The margin of error will be, it looks like they computed for us. So this table show more precise Z star. So this is Z star. So 1.28 Z star, if it's 80, they're asking for 80% confidence interval. If they're asking for 90% confidence interval, the Z star will be 1.64 and so on. So let me see if they have the example. So we have the formula as the following. The confidence interval have the form P hat plus and minus if, so this is similar to parentheses P hat minus M. So this will be the lower side, lower value. And then P hat plus M. M represent for margin of error. And margin of error, they compute by Z star times SE. And Z star changing on the table 9, depend on this, they say 90, 80, or 95, you will need to change these G star in this place. All the value will keeping the same from the data set that they're given. So SE is a standard error. You know standard error is compute by this, okay? By using that formula and plug it in here. Using that Z star depend on the percentage. And then you have the value for what we call confidence interval. So here is the example. The HuffPost government poll of 1,000 Americans found that 38% they believe that there is intelligent life on other planet. So our job with part A, we construct 95% confidence interval. And in your mind, if they're talking about 95% confidence interval, it means the formula will be what? The formula, I don't, remember you need to write the interval for me. Right now I write in short will be P hat plus and minus Z star. This Z star 95% will be number 1.96 right here. Okay. Z star, the formula will be Z star. Let me write down a formula for you. Z star times SE. Okay, and for this case will be P hat plus and minus 1.96 times SE. So SE you have to find by using the formula square root of P hat times with 1 minus P hat divided by N, square root of that to get it. So that is how you using the formula to find the confidence interval. And part B would be plausible. It means you have to conclude if it's 40% will be inside that 95% or not. So here's the steps. So the checking for central limit theorem steps, and we're having P hat is 38%. Let's look back to the problem. So they given us 1,000 as N, 38% as P hat. So we got using the we have P hat is 0.38, and we're testing for central limit theorem conditions, which is satisfied. Then we move to find the standard error. After we find SE, we're using P hat plus and minus 1.96 for that case, right? That's a margin of error. You will find the lower value and the upper value. So you put this inside the parentheses as the interval. You will have the conclusion will be 0.35, comma 0.41, right? So this will be called is the 95% confidence interval. Okay, that's a conclusion. Or, and then on the test, I would like you to write this too, would like this statement. to see. And part B, they're asking if 40% is plausible, is in this interval. Look like 40% is smaller than 41%. So it is plausible, right? So since 40% is contained within the confidence interval, so we believe that the intelligent life on other planet, so it's plausible. Okay, so that's how you solve it for this type of question, a confidence interval. And again, if you're feeling like I'm going too fast, so please rewind it, like listen back and forth and see the problem and pause so that you can understand this better by writing it down. So here using TI-84 to compute that. And again, you don't have to, if you do have TI-84, you can try this. It's simple, easy. If you don't, because I'm mostly focused on StatQuant, so I will show you StatQuant. To StatQuant, let me show you right now. And I will run a problem based on section 7.3 for you too. Let me see, this is 7.4, so I will run this first, then I will show you another one. Okay, so they want us to have, in order to run StatQuant first, you go to a StatQuant website or StatQuant website, or you log on Pearson and click on StatQuant here and click on StatQuant website, not dataset from textbook. So StatQuant website will be the part that we're looking for, and you open StatQuant, open it. When you click open it, you will got this window. So for this window to run StatQuant, let me show you how to run StatQuant on 7.3 first, because before you turn to 7.4. Okay. So for 7.3, let me open up 7.3 to see the data from a previous slide. We're talking about. Let me see, example. What example? This example. Hold on. 80 elected. Okay, 50. Okay, I can run this one, but the question finding for probability doesn't have it. So I will find the problem looking for finding probability. So this one according to 100. So this is not finding probability too, but it's applying a 95% confidence interval. So what you need to do is you just times 2 times SE to figure that out. And again, my goal is this one. This one. Okay, so this one talking about finding probability. So to find a probability that proportion, the actual story is, I think it's here. It's here, right? Okay. So, okay, I would like to run StatQuant to find probability for this type of question. Look like they given you P is 59% and 500% for N. And we need to find probability that a female is more than 63%. So I go to StatQuant. Let me open up StatQuant. I go to Stat. I go to Calculator. And then you go all the way to normal. Okay, so here look like this table, they having they cut it off to 50% for each. And our job, we have to fix this. You see right here we have standard. Standard is mean they're talking about the right and or the left tail. It would say standard is mean we're talking about the right or the left tail, which is, you see down here, P of X less than something. So this you can change to greater than for more than. So this case, we got more than 63%. We click greater than. Okay. So the between is mean, we're talking about the between area. Is mean you will type in the mean and the standard deviations, and you type in the value from the left and the right side so that smaller go to the left and bigger to go to the right. We got two types of doing it. You can convert all the raw score into z-value. For the z-value, the mean will be 0. Okay, but I would like to use the actual value, which is from the problem. So I will go back to a standard, and I will type in here the mean. I remember is 0.59, right? So 0.59, and the standard deviation for this case, actually you using the same method for this for chapter 6 actually, right? The same thing, but the way that we interpret is the standard error is mean the standard deviation for the sample distribution. So for this case, we found, let me open up 7.3 to find exact value. Sorry. SE, they don't given, but however, they given us by we computing by hands for this step, 0.022, right? So you got this by compute by hands, you type in 0.022. So remember when you convert this, so it looks like we are talking about decimal value right here. So I type in here as they're asking for finding the probability at greater than 63, right? So I will click greater or equal to 0.63, and I click compute to find the probability. So I have 0.03451817 is on the right side, as same as the textbook have. Let me see. So we got the same value. Let me check it. Right, we got the same thing. So the standard deviation, the mean, and we got this exactly the same by using StatQuant. So that's how we are using StatQuant for that one. So now I would like to show you how to find confidence interval for 7.4. Let me close this. And remember, when you do your test, when you want to copy this probability, you go to option, click copy, and follow direction from StatQuant. I'd like to close that for now. Let me see. I think I accidentally closed StatQuant. Oh my God. Okay, one more time. I accidentally closed that. Okay, now I will open StatQuant again. So now I'm currently logged on. So I just go on StatQuant's website, statquant.com. I have to sign in anyway. My laptop is kind of blurry right now. I hope you all can see it. I'm so sorry about this. I can't stop because I'm recording, so I'm so sorry. So I'm having the PowerPoint direct me. So first you go to stat, you go to proportion stat, one sample and with data, right? So we're gonna enter in the number of success, which is the probability that of the percentage of you may call p hat, and the number of observant, which is the sample size, and we select confidence interval and compute that to see the lower limit and upper limit. This will be the confidence interval. Okay, so let me run that for you. Go to stat and go to proportion stat one sample. Go to stat, go to proportion stat one sample with summary. Number of success. Let me open up 7.4 to see what is the value that they request. 38, right? 0.38, and we're talking about 95%. So I convert this into 0.38, and this is 1,000. You can see right here, number of success is 380. Let me see, 380, is it they given us 380 or 38%, right? So we convert that into a number because we so remember to convert that into a number. So 38% is mean 38%, you multiply, or 0.38 times 1,000, giving you 380. And I go to, so I compute on the side. I have 38%, it means 0.38. You time with 1,000. Is it they given us 1,000? So I using my calculator, I'm having yes, this gives me 380. So I put it here, I type it in here. 380. Number observant will be the number size, which is 1,000. Chapter 8 will be hypothesis test. We don't do chapter 8 right now. We do confidence interval, so you change that. Now it's 95%. Some question may asking you like 90%, you change that to be 90. It depends. Okay, so now this time the question is 95. I put it 0.95. Click compute. After we click compute, you notice the value that we are having. The lower limit will be 0.34, or you can round up to 0.35, which means the confidence interval. So we believe that we have 0.35, so I'm rounding up, comma. So this upper limit, this lower limit, 0.41 is the 95% confidence interval that contain a mean. That's contain the true population. You might say the mean if it's talking about a mean, okay? Okay, so that is how you draw a conclusion in words. Remember to convert percent into an actual number from here to here. So then you type in, you got the value. That's how you do it for confidence interval. Okay, so let me erase this. So this is how to compute confidence interval for section 7.4. Remember SE, you have to figure it out by yourself by hands. You have to compute by hand first. Okay, before you plug in, then you have to do it on your piece of paper and copy it down. Okay, so let me go back to 7.4. So we got the same thing, we got a value. And here's another example. So look at this one, we are having random survey 300 voter. So this looks like our N, right? And this is 165 is already become the number of success. So you don't have to convert it out. You convert unless when it's become percent, then you have to convert that by multiply it with the sample size. But this already have it here. You just type it in exactly 165, and the number of observant will be 300. You don't have to convert it. So this is 99. But before you do all of this, make sure you have to find SE by yourself too. They're talking about they're having a survey with 300 voters. 300 voters, and of the 300 voters they survey, we are having 165 people. They indicate that they will vote for the candidates. And the question is, we have to find or compute or using 95% confidence interval. So in order to answer, should the consultant predict the candidate will win the election or not? So we have to find a 95% confidence interval before you can answer that questions. So over here is compute by hands. We are having the following. Actually, for this type of problem, we have to compute by hand with the steps, and then you can run StatQuench, okay? Because we have to find SE before we can run StatQuench. So here is the step. We need to compute by hands. We're checking the central limit theorem conditions. If it's met, then we keep doing by finding the standard error. So here, random, independent, and sample, you can write this short. Secondly, is you testing for n time p hat or time p, and n time 1 minus p hat. And again, for this case, p or p hat is kind of roughly the same, but I would like to point out for this case, it have to be p hat because 300 is our sample. And from that sample, you're taking another smaller sample, which is 165 from that 300. So that's why it's specifically that number 165 divided by 300 will be the p hat. So so in order, sometimes they provide us p hat, sometimes they don't. Like previous example that we talked in the last lecture, we are having the percentage of the p hat, but this time they don't give us the percentage anymore, so we have to compute that. So by using the formula, you take the sample, the number of the success, divided by the total number, okay? Or in StatQuench will be the number of success that you type in, and this will be the number of the observance. So we got a value, you're testing it, 165 is greater than 10, so we pass that requirement. And then you want to take 10 multiplied by 300, you assuming that the population, the entire population will be about 3,000. So that's at least 3,000, right? So all are met, then we will do the next step, which is we find the standard error. So by using the formula for the standard error, we're having this, and we found 0.0287. In other words, this will be 2.87%. So from here, then we go ahead and compute by using StatQuench. Otherwise, you can keep finding the margin of error by take the value of 90. So in this case, it's 99. So 99, this Z star would be 2.58 for the Z star. And then we multiply with that SE to get a number 0.074 become a margin of error. That's how you compute. Where do you find Z star? You find Z star in the table, in the section 7.4 from PowerPoint. I think in the table, I don't remember. Okay, so this is the table 9. So you will give you that value. Depend on the percentage of confidence level, you choosing the correct number, Z star right here. Okay, so let me go back to page 19. So here, next step, we compute by, for the people keep computing by hands, you will take the p hat minus the margin of error. You got the first interval. Now you got this interval. Doesn't have to be the first or the third. And then you're gonna take that value, you add with 0.074. So this here, they make it wrong. So let me annotate this again. Sometimes the textbook have the wrong compute. So we have this 4. So please change that for me. And you're gonna help me. You take 0.05, add with 0.074. Let me see. I'm gonna use my calculator. I have 0.55 plus 0.074 giving me 0.624. Okay, so this is the textbook mistakes. So have to be, so I cross out this 0. So it will be 0.624 will be the second interval. So like they rewrite as here, right? See? So the 99% confidence interval is from, remember to put inside the parentheses, from 0.476 to 0.624. So that would be the interval. So this interval telling us we are confident, we are 99% confident that the true population that we are looking for will lie between these two values. That's for sure. So since the interval contains the plausible value that are less than 50%, less than 50% consultant might not predict the candidate will win the election. So right here it looks like this the value that we found right here, we having the p hat is 0.55. 0.55 estimate is p hat estimating the true population will lies in here, in between here, right? And the value, so let me go back to the question to see what do they want. Go back to the question they're asking. So we found a confidence interval, and we would like to know, should the consultant predict that the candidate will win the election? So it looks like the value that we found the interval will be about 46% to all the way to 62.4%, right? So because in order to win, usually the value have to be greater than, at least it's 51%, right? So it might be the answer from here is saying that it might not predict the candidate will win, because maybe the estimation of the interval here is only 47.6%. It's less than 50%. So that's why it's hard. Like we have some doubt that we cannot predict. Okay, that's what it means. And the confidence interval are frequently constructed using the technology. So this is StatQuant's output of the confidence interval based on the polling. So right now I want to run the StatQuant to find confidence interval for you to look at it. I want to open StatQuant. Let me see. Let me minimize this. This is just like the video, I think. Let me see. It is the video. Okay. So let me log on. You can log on by using StatQuant's website, but you have to sign in using the same account for Pearson. And then open StatQuant. So we have this value. You go to stat, right? And you go to summary stat. Let me see, not summary stat. Stat, and go to all the way to proportion stat, one sample, or with summary. And then you type in the number of success. I remember is 165, right? The number of observant will be 300. We don't perform hypothesis tests. That is for chapter 8. We're doing the confidence interval, and we're not doing 95% confidence interval. We're doing 99. And let me see. It looks like they don't have the spot for us to type in the standard standard error, right? Let me see if we compute the correct value. Yeah, so it looks like we don't need a standard error. Standard error is compute by hands for and for using for finding in beginning of 7.4 or 7.3. Okay, so we're having the value right here. Let me maximize this. So the count is, by using this system, we're having the value, the sample proportion they compute for us is 0.55. And the standard error is like we compute by hands, we're having this value. Lower limit is that, and upper limit is this. So this is how you, when you're using StatQuant, remember to show step by hand for me, like checking for central limit theorem first, and then run StatQuant. Because in StatQuant, I can see p hat, I can see standard error that you don't need to compute by hands, upper limit, lower limit, and auto count here. What you need to do is you need to copy and paste option. You go to option and copy it, okay? And you can paste on the document, on your document. Okay, so that's how we do it. So let me reopen the PowerPoint. We got the same value, right? And this table is helping us to visualize the 68% confident interval, 95% confident interval. It will be from here to here for this case, and 99.7 will be from here to here, and 99.99 is almost 100% will be from here to here. So the more confident interval that we are having is telling us to will be more confident that we will include the true population, will be including the correct populations in between that interval. Okay, that's what it means. Okay, so I'm finished 7.4. Again, if you don't have any question, I move on to 7.5. If you do, please write the question on the side and then email me. Okay, let me open up 7.5.